Hello everybody. I wanted to create another video lecture to talk about forecasting. The reason for this is twofold. One is to help some people who have some typical problems that come up in the assignment that I see, clarify some issues regarding how to calculate errors, the MAD and the MFE and whatnot. And secondly, and perhaps more importantly, forecasting is one of the topics that is commonly cited by the students as the one they enjoyed the most, and I want you guys to get the most out of our forecasting discussion in this course. So I thought I would record something, share my pointers and ideas about forecasting with you, and hopefully make this whole thing work out really well. The other reason, of course, is that this is something that you guys are all going to probably use most often or most likely as you go into your work in the real world. Some of the other things like probabilities and whatnot may not be encountered too much, but forecasting is something that just about every business school graduate will actually do. Okay, so let's take a look at some basic forecasting methodologies. What I have here is a series of numbers. Okay, this data set is about US new car retail sales. For each month, a certain amount of cars have been sold, and I have this data from January 1998 to November 1999. The actual numbers don't really matter. Okay, this could be number of donuts that were made, it could be number of beer bottles, we really don't care. Okay, what we have here is a time series data. It is a series of numbers that tell us how these numbers have changed over time. And the basic idea behind time series forecasting is that if there is a trend, we want to identify that trend. If there is a pattern in the way this data has changed over time, we want to identify that pattern because we are going to move with the assumption that whatever has been happening is going to continue to happen. Okay, if there is a pattern here, then we are going to assume that that pattern is going to continue, and if we can identify the direction and the shape of that pattern, then we can extrapolate that into the future and come up with our forecast. Okay, so just to give you a quick idea of what this will look like, if you graphed it, we will talk about graphing later, but let's take a quick look of what this looks like as a line chart. I will drag this into the screen. So this is what it looks like. Okay, there is a pattern. You might say there are different types of patterns here. You can see that the data went up and then it went down and then it went up again and it starts to come down. Okay, so looking at this, we can see a few things. In the latter part here, and I'm not really sure how to draw a rectangle around this, so just bear with me. In the last few data periods, we can see that the data is coming down. Okay, so we are going to assume that this downward trend that you see in just this last little bit over here, that downward trend is going to continue, we are going to assume, because we see that pattern. We also see a pattern of cycles. Up, down, up. This seems to be coming down again, and then at some point we are going to assume that it's going to keep going up. It's going to start to go up, just to follow this pattern. Okay, so we could see two types of patterns here. One of them is a cycle, a seasonality, and then the other one is a short-term trend moving downwards. But this is just for inspection. We are not really going to get too much into looking at these different types of patterns here. The point is, when we do time series forecasting, we are basing the whole thing on this very fundamental assumption. Whatever has been happening is going to continue to happen. Okay, otherwise we have no way of knowing what's going to happen, so we're just going to basically say, well, I think that sort of thing is going to continue to happen. Alright, now let's take a look at a few different ways of forecasting. The simplest way to forecast what's going to happen next in October 1999. The question is, what's going to happen here? Okay, let's come up with a forecast for this. The simplest way you can come up with a forecast is called naive forecasting, which basically nobody uses. If somebody asks you the question of what's going to happen next, the simplest assumption that you can use is whatever happened this period is going to continue to happen in the next period. Okay, so the forecast based on the naive forecasting methodology would basically say next month's forecast is equal to what happened in the previous month. So my forecast for October based on the naive forecasting methodology would be 48,513. Why? Because we sold we sold 48,513 cars this period. Since that's how much we sold in November, we're going to say, well, I guess we're going to sell that much in October. Is this a good forecasting methodology? Well, maybe, maybe not. You know, if how close are we going to get to an actual figure if we just assume whatever happened this period is going to happen again? Probably not very close, but you know, it's something. So this is called the naive forecasting methodology. Okay. Now another thing we can do is to look at more than one past period. Naive forecasting methodology just looks at the past period and says that's what's going to happen again. We could have a 2-month moving average. Meaning, instead of just looking at the last month, instead of just looking at this, we could say next month's output or sales is going to be an average of what happened in the last 2 months. So it's going to be 50,000 plus 48,000 divided by 2. That's the average of the last 2 months. That tells me that the forecast is going to be 49,300. Is that forecast any better than the 48,513? I don't know. We don't know what's going to happen in October, so it's difficult to figure out which one of these forecasts is better. Now you can, if you like to, you can increase the number of periods that you're looking at. You can also look at a 4-period moving average if you like. That would involve us taking an average of the last 4 months. Divided by 4. Okay, so if you take an average of 56, 52, 50, 48, then the forecast for next month is 51,714. Is that better than the other two? Well, we don't really know. Okay, so here's what we're going to do. How can we know? How can we figure out which one of these forecasting methodologies is getting closest to the actual figure? Well, we don't have the actual figure for October 1999, so we cannot compare the actual number with the forecast that we have. But we do have the actual number for November. Okay, we actually know what happened in November 1999. So we can say to ourselves, if we used these 3 different forecasting methodologies to forecast what would happen in November, then I could actually see which one of them got closest. Okay? So the forecast based on the naive forecasting methodology for November 1999 would be basically whatever happened in October. Okay? So we sold 50,000 cars in October, and since naive forecasting methodology says whatever happened this week or this period is going to happen again next period, the forecast for November would have been 50,087 cars again. The actual number turned out to be 48,000. Okay, now we have some sort of an idea how close that methodology got. Let's see how the 2-period moving average would have done. The 2-period would have moving average for the forecast for November based on the 2-period moving average would have been October sales figures plus September sales figures divided by 2. So based on the 2-period moving average, my forecast for November would have been 51,132. Now I can actually see which one of them did better. Okay, it actually looks like the naive forecasting methodology got closer to November 99's figure than the 2-period moving average did. Okay, now I have something to base it on. Let's take a look at the 4-period moving average. Okay, this would be, I'll just type in the Excel function here. This would be the average of the last 4 months, like that. Okay, so the average between July, August, September, October would have been 53,198. So if we did not know what happened in November, okay, and we used the 4-period moving average for our forecast in November, we would have gotten the answer of 53,000. So among these three, which one is the closest? The answer is the naive forecasting methodology is the closest. Okay, I'm comparing it to an actual number. Now, does this conclusively prove that in this case the naive forecasting methodology does the best? The answer is no. We cannot conclusively make a decision on which methodology to use just by looking at one period. Okay, well, naive forecasting methodology did the best in when comparing to November, but that's only one period. If we do the same thing for the other periods that we have, we can see on average how well each of these methodologies will do. Okay, so let's pretend this time that we did not have October. Okay, let's pretend we did not have the actual number for October and we wanted to forecast what was going to happen in October. The forecast using the naive methodology for October would have been whatever happened in September. That would be 52,000. The forecast for October using the 2-period moving average would be the average of the 2 months prior to October, September and August. And then I'll just copy the formula up. The average based on the forecast based on the 4-period moving average for October would be 54,000. The actual number was 50, naive said 52, 2-period moving average said 54, 4-period moving average said 54. Okay? Alright, now, naive is still looking better than the others. But we have only tested on 2 data points. We do not have to stop now. Okay? Why not test it some more? So what I'm going to do is I'm just going to copy these formulas up for a little while. Let's go until here. Okay, so what you see here is how each of these 3 different methodologies would have forecasted what was happening for what was going to happen for each of these months. Okay, now this is a lot of numbers to look at. We want to see overall which methodology got closest. And we could do this by visual inspection. If, for example, in June, the actual number was 51, naive said 49, 2-period said 48, 4-period said 46, naive got closest. Let's look at something else. Let's look at this one. In December, the actual number turned out to be 44. The forecast by naive was 42. The forecast for by 2-period was 44.5, and the forecast by the 4-period moving average was 44.7, 44.8 almost. Okay, in this one, the 2-period moving average did the best. Let's look at another one. Looking at another one, let's look at, for example, this. The actual number for April turned out to be almost 51,000. The naive forecast said 54. 2-period moving average said 49, almost 50. And 4-period moving average said 46.5. So in this case, 2 period got closest. Okay, so we can see that in some instances, one of them got closer to the closest to the actual number, and in some other cases, some other one got closest. So how are we going to make the final determination of overall which one of these is working best? That comes by something we call the forecast errors. Okay, here's what we do. For the naive, we are going to, for all of them actually, we are going to calculate the errors. The forecast errors by naive forecasting. And that is going to be simply, let me just color code these so that you don't get some of the lines confused. Okay, these three in the middle, let's make those blue. These are the forecasts. Okay, the new columns I'm going to calculate the errors, I'm going to make them red. In fact, why don't I go ahead and just make them red right now. Okay, so here's what I'm going to do. I'm going to say, look at the actual, subtract from it. Let's do it the other way. Look at the forecast by naive forecasting and subtract from it the actual. This tells you how off naive forecasting was. Okay, how much of a mistake, how much of an error naive forecasting made. So naive forecasting was about 2200 cars below what the actual number was. Okay, if I copy and paste this down, you can see how close it got overall. Okay, you can see that sometimes it was below and sometimes it was above the actual number, which is normal. Sometimes it gets really close, it got within 400 there of the actual number, it got within 470 of the actual number there, but sometimes it was really far off. Over here it's 8,000 off, over here it's 5,000 off. Okay, so for example here it's 8,600 below the actual value. That's what the forecast for naive did. Over here it is 4,800 above the actual value. That's what the forecast did by naive. Okay, now what I can do, since there are a bunch of numbers here, what I can do now is to actually take an average of all of these. When I hit enter, the number that you're going to see is going to be the average amount by which naive forecasting was off of the actual forecast. The average amount of error that the naive forecasting methodology made. And the answer is, wow, remarkably close. It's 39. On average, naive forecasting got within 39 cars of the actual value. Now let's look at, I did not do these numbers ahead of time, so this is actually surprising to me. That's phenomenally close when you think about what it's trying to do. Okay, so the errors by 2 period moving average. Let's take a look at that. 2 period moving average, here. We subtract from the forecast the actual value. Okay, so in the first month it was 3,200 cars below the actual value. Let's copy and paste this all the way down. These are the numbers that you see. There is a 10,000 too low, and then you see a 4,000 almost too high, another 3,700 too high. It got pretty close there, 389. It got pretty close here, 203. Let's take a look at the average. The average of all the errors made by 2 period moving average was, what do you think? Is it going to be higher or lower than the naive forecasting? The forecast, the average was minus 39. Okay, now I'm thinking, I wish I had done these numbers ahead of time. That is a phenomenally interesting coincidence. Okay, and it is a coincidence. It is a really, really unlikely coincidence that these are like that. And if I had done this, I'll show you in just a second. If I had done this one column, one row too little, or one more row, then these numbers would not match. But I just picked June as a random point and they are matching. Anyway, so let's take a look here. What about the errors made by the 4-period moving average? Okay, the error would be the forecast by the 4-period moving average subtracted from the actual. So in June it was about 5,400 too low. Okay, extend this all the way down. Here are the numbers that you see. It got almost right on the money there. Look at that, -1. And then it had a huge mistake there, 10,500 too low, and it had a few too high situations over here, for example. Let's see what the average was. I could just copy and paste, but this is more exciting. The average error for the 4-period moving average was, what do you think? -431. So the 4-period moving average did not do nearly as good as the other two methodologies. Okay, and this is what I was saying. If I had not done two of these, I'm going to delete these. If I had just looked at August through November and not done June and July, the numbers would have been like this. 2-period moving average does better than the 4-period moving than the naive forecasting methodology. Anyway, but I did, so I'm going to do undo and keep these 39 and -39. Now, if the situation was like this, how would you pick which forecasting methodology to use? Well, if we had only inspected August through November and we had seen these numbers, -84, -128, -431, then we would go with the 2-period moving average forecasting methodology. Why? Because on average we can see that that methodology does the best. Okay, on average. Now, since I had looked at these 2 months as well, we have a tie. On average, the naive forecasting methodology was about 39 cars too high. On average, the 2-period moving average was 39 cars too low. So these are pretty much equal. Okay, how are you going to pick between these two? Well, one answer could be it doesn't matter which one we pick because they're equal, and that might be one way to go. But there is another way to look at these things, okay? And that's the last thing that I'm going to show you. What we did here is called the mean forecast error. Mean forecast error. Mean is the same word as average in statistics, so this is the average forecasting error. Okay, we looked at the errors and we took the average. The other thing we can look at is called the mean, average, absolute deviation. And the idea goes like this. The reason this turned out to be so low, both of these turned out to be so low, is that the times when they are too high is offset by the times when they are too low. Here's a huge mistake, 8,000. But at the same time, here are a couple more instances where they are too high here and this is too low here, so they offset each other and you end up with an average error of 39. What if you did not want your too high mistakes canceling out your too low mistakes? Because after all, these are still mistakes, okay? Although this looks like the forecast comes phenomenally close to the actual number, that's not really true. It's making a lot of high mistakes and it's making a lot of low mistakes. And when you take the average, those are canceling each other out. What if you don't want them canceling each other out? What if you just want to see this is a mistake and this is a mistake, and I don't want this -2,000 to cancel out this, is it a +2,000? Yes. I don't want this -2,000 canceling out this +2,000. What if you don't want that to happen? Okay, since they are both mistakes, you want to take into account all mistakes. And here's what you do for that. You calculate the absolute deviation, the absolute value for each of these numbers. Absolute value means you remove the sign. Okay, So minus 2268 becomes 2268. If it's a positive number already, it's still positive. So if we copy and paste all the way down, these are all positive numbers now. Okay, so that's a mistake of 2000, that's a mistake of 5000, that's a mistake of 1250, that's a mistake of 400, that's a mistake of 2189, and so on. These are all mistakes, and they all have the positive sign, so none of them are going to cancel each other out. Okay, and if you take an average of this will tell you the average mistake without allowing the numbers, the positive and the negative numbers, to cancel each other out. This is going to show you what the average mistake is, and the answer is the average mistake made by the naive forecasting methodology was 2700. Okay, let's see how that compares to the 2-period moving average. So I'm going to take the absolute value of these numbers, copy it down. These are all the mistakes. There are no positives and negatives here anymore. They're all positive, meaning none of them are going to cancel each other out. Let's take the average. What do you think? Is it going to be higher or lower? Okay, time is up. 2649. They are pretty close still, but this one, the 2-period moving average, does better. Okay, so here's what you learned. You learned what forecasting is all about. Forecasting is all about looking for patterns and basically assuming that whatever pattern exists is going to continue. You learned several different methodologies for forecasting. Here's a naive forecasting method, 2-period moving average, 4-period moving average. If you look in the book, and you will have to do the assignment, you will see weighted moving averages, you will see exponential forecasting, and a whole bunch of other stuff. Okay, and you also learned how we pick between different methodologies, because remember this, ultimately forecasting is easy. Forecasting is a fancy term for guessing, and anybody can guess. Forecasting well is the challenge, okay, because anybody can come up with a number. What's going to happen in October? I think we're going to sell 120,000 cars. I just made that number up. Is the forecast? Sure, it's my forecast. Is it good? Well, okay, we don't know if it's good. And how do we tell if a forecast is good? We look at the previous data that we already have. We compare how they would have forecasted for that information that we already have, and we calculate either the mean forecast error that you see down here, or we calculate the mean absolute deviation that you see up here. Okay, and based on how well they are doing with respect to these two measurement methods, then we pick based on those. Any questions? Of course not, because you're not actually here. Okay, I have one other thing that I want to show you. This is going to be more towards your final problem in the assignment. It's pretty quick, so I want to just show you how we do that sort of thing. So we have all this stuff that we calculated by hand, basically. Okay, and you'll have to do this for questions 1 and 2 in your assignment. But we can do something else. Once we have this data, I can chart this. Okay, insert line chart over here, move it into the screen. There it is. I'm going to make it bigger, a little bit bigger for you, so you can watch more comfortably. Okay, this is my data. Now here's something nifty that I can do. You'll have to read the book to get the full details on regression methodologies and whatnot, but I can do this. I can right click on it. That's what I did. Okay, I right clicked on the line itself, and I'm going to say add trend line. When I do that, you're going to see a new dialog box come up, and it's going to ask me what kind of trend line do I want. And I'm going to pick one of these that you see here. Here's a moving average, period 2, period 3. You can change it if you like, period 2, period 3. Hey, look, you can actually see the line over here. You can see how close this gets. Okay, 3 period, 2 period, It doesn't do naive, which would be a 1 period moving average. Okay, you see the changes. We can do linear, which is a straight line. We can do exponential, which looks like a straight line, but it's really not. We can do logarithmic. There's a curve here that you can't quite, see very clearly. We can pick a whole bunch of different options. So I'm just going to pick linear, and then I'm going to say display the equation on the chart, display the R square on the chart, and I'm going to say close. And you see here, this is the straight line that Excel thinks fits best through the data that I have. Here is the formula for that line, and here's the R squared for that line. Okay, once you read about R squared and regression and whatnot, well, you read about R squared and regression in Unit 4, so you should know what this means by now. So this trend line can account for about 39, which is, okay, let's call it 39. About 39% of the changes, 39% of the variation that you see in this data. Okay, you can add additional trend lines here. If I add a moving average, there is no trend line, there is no equation or R squared, because moving average is not a single line. Let's add polynomial. Okay, let's add exponential. Display the equation, display the R squared. I can see the formula here, it gets pretty close. Let's do polynomial. The numbers are not really changing, so I'll just stick with exponential, show you that. The lines are almost on top of each other, so you cannot really see them. The formula for the exponential line is right there. The R squared for the exponential line is almost identical to the R squared for the straight line. Okay, if the numbers were different, then this would actually change. If I delete some of this over here, then these numbers are going to change a little bit. But let's not confuse the issue. Anyway, so this is how you attack question number 3. It's actually, as you can see here, pretty simple. All you have to do is click on the data line and pick add trend line, and then pick the kind of line that you want. And this actually gives you an easy way of forecasting too. Except we are not doing moving average, we are not doing exponential smoothing, we are doing a line estimation. And this is a straight line, linear. Then the second one is exponential. Okay, so that was about 33 minutes of fantastic stuff. I hope you enjoyed forecasting. I don't want to bore you guys to death, so I'm going to stop here. But as usual, remember that the full details are in your book. It is very difficult for me to actually explain all of this from the beginning to the end. It would take several hours, so I'm going to leave it up to you to read the topics. Okay, so that's it. I hope this helps you with your assignment and your general understanding of forecasting. I'll see you on the discussion boards. Have a good night, I guess. Bye bye.